Hello guys, welcome to the vertical projectile motion question. This topic is challenging for many students, and in my presentation I would like to unpack it and make it easy for you to attempt and ensure that you are excelling in this topic as you do in other topics. Alright, so let's take a look at the question. Alright, so we are given a scenario in words and also with an accompanying diagram, as you can see here on the board. Right, so there's a building here which is 25 meters high, and there's a door that is given which is 1.9 meters high, and from the top of the building a ball is thrown vertically up at an initial velocity of 12 meters per second. Okay, so we are asked in 3.1 to define what free fall is. Okay, so what is free fall? It's motion in which the only force acting on the object is gravity. Okay, we can say weight. Okay, easy marks to get, and that is your definition questions that gives you the entrance to the rest of the questions, okay, which will be applications definitely of VPM. Now, because we're given two dimensions here, we can anticipate that there will be a question that will ask us to talk about this dimension there. 25 minus 1.9 gives us 23.1 meters. Okay, and this is when the ball will be right here, still moving downwards to the ground. Okay, we'll see when and how we will use that measurement. Good stuff. So we've answered 3.1 now. Let us go to question 3.2. Here it is. Right, so in question 3.2.1, we are asked to calculate the time it takes for the ball to move from the top of the building all the way to the maximum height of the motion. So now, what do we know about this point right here in the motion? That the velocity, Vf, will be 0 meters per second, and this is classified as our initial velocity. Okay, we know that gravity is 9.8 meters per second. We're going to choose up as positive, so it will be negative 9.8 meters per second square. Okay, so we choose up as positive. Okay, so now choose one of the equations of motion. We have Vf equal to Vi plus G, change in T. This is a relevant one, not the only one. There are many alternatives that you can follow here to get to the same answer. So this is 0 equal to 12 plus negative 9.8, change in T. So therefore, what is the time taken for this motion with an initial velocity of 12 meters per second, and it ends up stopping momentarily at the maximum height, experiencing this gravitational acceleration downwards? The answer that you get there is 1.22 seconds. Okay, so it takes 1.22 seconds for the ball to reach the maximum height. Great stuff. Let's go to 3.2.2. Here it is. All right, now we want the velocity with which the ball strikes the ground. So when the ball hits the ground here, we are asking what is Vf. We know what is Vi, and this is our initial position, and this becomes our final position. So therefore, what is the displacement there? Is 25 meters down. Okay, so then we have what we need. Let us go to one of the equations of motion. We can use this one. Vf square equal to Vi square plus 2g change in y. Okay, what is our change in y? That is our displacement right there. So actually, let us use initial y, final y. The difference there is the change in y because we are in the vertical plane. All right, good stuff. So final velocity, we are looking for that one. Initial velocity is 12 plus 2 is negative 9.8. Displacement is downwards, so this will be negative 25 because we chose up as positive. Okay, if you do the calculation there, guys, you take the square root, VF ends up being 25.18 meters per second. All right, and that takes care of the velocity when the ball hits the ground. Good, let's go to the next question. All right, so before we answer question 30.2.3, just want to add here in the previous question, direction here, it's downwards, right? So there's a marker location there for indicating correctly the direction. So this is final velocity when the ball hits the ground. We can put it in there, 25.18 meters per second. Okay, so what is happening with question 3.2.3? We are asked to calculate the time it took the ball to move from the top of the door to the ground. So we've anticipated that, right? So the displacement from the initial y, and this becomes the final position now that we're going to assume. Okay, 23.1 meters down. Okay, so we'll need to calculate this final velocity using that initial velocity for this motion. Okay, and obviously not including that part of the motion, but this part of the motion. You want to know what is that one. Okay, and the equation that will help us is this one. Vf squared is equal to Vi squared plus 2g change in y. So we have 12 squared plus 2 times negative 9.8 times negative 23.1. Again, displacement is downwards. If you take square root there, you'll get that Vf is equal to 24.4287 meters per second downwards. Okay, so we got that to be the initial velocity now for which part of the motion. This comes in there, but it is actually the Vi for this part of the motion, the last bit of the motion, which is 1.9 meters down. Okay, because already we have the final velocity from the previous question, and go back to this equation. Vf equal to Vi plus g change in t. Okay, so how long did this motion take? So Vf is 25.18 and Vi is 24.4287 plus negative 9.8 change in t, and the time that you will get there is 0.08. There is it. Okay, so this takes care of question 3.2.3. Let us look at question 3.3 now. All right, so in this question, we are asked to draw a velocity time graph and indicate these quantities, right? Still choosing up as positive, we have 12 right here, and we know that it decreases all the way to the maximum height, and that part of the motion took 1.22 seconds, and this is what we want to see there. Okay, and then it went down. Okay, so this is in the negatives. Okay, so in other words, we continue, and at some time there, we have 25.18 as the velocity there. Okay, so this is the velocity time graph for the entire motion from start to finish when the ball hits the ground. Okay, so guys, thank you. This takes care of question 3. I'll see you in the next video, question 4, which is an interesting question, and believe you're also looking forward to it. For now, keep well and keep working. Sharp, sharp.